What's up, everyone? Christina here from the Glaser Tutoring Company, and today we are going to solve another one, right? Another one. But today we're going to be solving a system of equations by substitution. Okay, so we have a beautiful system here. I'm just looking at these equations, right? And I see that for both equations, I just have an x, right? I don't have x squareds or x cubes. And the same thing goes for the y's. If you have just an x raised to the first power, which are what these are, and the y's as well, these are both linear equations or linear formulas or linear functions. And a combination of two or more equations that are maybe potentially interacting with each other, that is called the system. So these two are part of the system. In order to have a system of equations, you just have to have two or more. Now, in this case, we want to solve. So we want to solve this system. Well, what does that mean? Well, if we do talk about these, right, we just said that they were linear lines. And if they are interacting with each other, they might cross paths at one point. And that's what we want to solve for. We want to solve for that exact point that they are communicating with each other or they have a relationship with. And if they're crossing paths, in this case, maybe at one single point, that's the solution. So the solution is that one single point that they have in common. So essentially, we are looking for a x, comma y, right? We're looking for the x value and we're looking for the y value in which they both have in common. Now we have to do that via substitution. Well, what does that mean? Well, the first thing is if you're going the substitution route, because there's two methods of doing, solving systems of equations. One is substitution, which we're going to be doing here. The other one is the addition method, or sometimes called elimination, which we'll have tons of videos on that as well if you want to check the channel out to look at those. But in this case, we're just going to do substitution. And the first rule of substitution is to say to get one of your equations. So let's just label this equation 1 and equation 2. One of these equations into either x equals or y equals. Now, in theory, it does not matter which one you choose. So you could change this negative 3x into x equals, 12x into x equals, negative 4y equals, and the y equals y equals. Y equals y equals, y equals y equals. That reminds me, I laugh every single time when I hear that commercial of, "Hi, I'm Morgan. If you've heard that commercial, right? The injury law attorneys or whatever. "Hi, I'm John Morgan. I can't. But anyway, if you know a commercial or usually it's on the radio, maybe it's on TV. But yeah, if you've heard of it, let me know. Am I the only one? But anyway, so we have to find out x equals or y equals. Now, the easiest way to do it is if you see a lonely guy, right? If you see maybe like x plus 7y, if you see that you have an x and there's only one in front of them, that's the chosen one. Same thing with the y's. If you see, 2x plus y equals and there's only one y, that's the chosen one. And I see here it is, the single y. This is the easiest one to change into y equals. Now, obviously, you don't have to go for this one. You can try a different one if you want. You'll get the same answer as me at the end of the day. Meaning the same solution, whatever we come up with the solution. Okay, so what I'm going to do is I'm going to take equation 1 and I'm going to solve for y equals. So, x. Okay, there we go. So we have negative 3x, and maybe what I'll do is we'll write it in the middle here, and then I'll move it on to the side. So 3x plus y equals 2. So I want to solve for that y, so let's shimmy over the x's, right? So we're going to plus the 3x, because it was a minus, plus 3x. This gets canceled out. Goodbye. And we get y equals 2 plus 3x. So now we know what the y equals. Y equals 2 plus 3x. So that's the first part of the substitution method. Now what I'm going to do is, this is the important part, guys, that whatever formula you used, so we used equation 1, you have to now use the other equation. Because what we're going to do is we're going to take equation 2, so let's just write that out, equation 2, which is 12x minus 4y equals negative 8. We're going to take that y value that we just solved for and plug in 2 plus 3x. So essentially, this is why it's called substitution, because it's like a substitute teacher. Here's the real teacher. Whoop! Wasn't there that day. And this guy is going to come in. But just make sure, because this negative 4 is being multiplied by the entire y. So we have to now take that negative 4 and times it by the entire 2 plus 3x. So let's go for it. So I'm going to say 12x minus 4. Now what was that y really equal? Well, it was really equal to 2 plus 3x. So we're just literally boop, plopping that in. Oh, that was a beautiful fit. But I got to write it over. 2 plus 3x. And now this, just keep picking it up, equals negative 8. And now we're just going to use our PEMDAS, use our algebra. Seems like we got to distribute a little bit here. So we got 12x. Negative 4 times 2 is a negative 8. Negative 4 times 3 is a negative 12x. And this equals negative 8. Okay, let's keep going. But now, 12x, right? I'm going to group like terms. 12x minus 12x. Oh, that's interesting. Because what's going to happen to the variable? Yeah, it cancels, right? 12x minus 12x, that's 0. You lose the variable. Okay. But now we have to analyze the ending results. So at the end of the day, we had, we'll do it in blue, negative 8 equals a negative 8. So let's write that down. Negative 8 equals negative 8. Now, when we have this outcome, right, when we lose the variable, you could have two options. You could have the first option, which we have here, in which both numbers are the same. And as a complete, algebraic sentence, this does match, right? Negative 8 equals negative 8 because it's negative 8 of Morgan. I swear it's coming back. Is that the new, Rick roll, right? But anyway, negative 8 equals negative 8. This is a true statement because it's the same number. The other option is if you lose the variable and you get a different number on the left and the right side. Then this is the big fat no. But in our case, we have both numbers on the same side. So that has to mean something different than the other situation that we might see. Now, if it's the same number, right, if this is a true statement, that means that since you lost the variable, all possible solutions are acceptable. And literally, an infinite amount of solutions are present here. So we're not actually, in this case, we're not actually solving for, we can't even solve for that one specific point. Because if we lose the variable and negative 8 equals negative 8, that means that this side is identical to this side. So we'll say that these are the same lines. They're identical. So if I plot one linear line, right? And then if I'm going to plot this other linear line, guess what? If it's identical, it's literally the same thing. And now talking about how many points that they have in common, all these, right? There's an infinite number. You could choose, from the bottom. You can choose from the top. There is an infinite number. Did I spell that right? Infinite number. And maybe I'll put this over here. So there's an infinite number of solutions. That's why we can't just get one here. And that's why you drop the variable. But this is the answer. That solve for this system of equations, we technically, by dropping the variable, we actually did solve because Now we know that they are the same exact line, same slope, same y-intercept. So this will be an infinite number of solutions because it's literally the same. So yay. Thank you so much for viewing the video. I hope this helped. Let me know in the comments. Just make sure that, I'm doing my job right here. And, by subscribing, by commenting, by liking the video, it just gets this video out there that this channel exists. So thank you so much. You guys make the channel what it is. We just reached 50,000 subscribers, which is absolutely incredible. And it's all because of you guys. So thank you, thank you, thank you. And we're going to keep doing what we do on our end. We're just going to keep producing videos. So I hope you guys have a great day, and I'll talk to you soon, okay? All right, bye-bye.